Hello YouTubers! In this video I want to show what does it mean to say rocket science and what stands behind these two words. Rocket science celebrating 60 years of cosmonautics or astronautics with first man Yuri Gagarin flight in cosmos in 1961. In present times, space race comes to fashion, except in present times are between billionaires, when in 50s and 90s, space race was prerogative of governments, Soviets versus USA, Cold War arms space race competition. Today is new resurgence of rockets in media news, only now it is prerogative of ultra-rich people. That is also a historical tale to how rocket science was transformed to computer science. The highest points of technology level became not space but electronics science branch. In this video, rocket science still is a simplified mathematical model, additionally example with numerical calculation. Real theoretical physicists never touch numbers. Real theoretical physicists only deals in symbolical abstract mathematics language. I want to put rocket science in perspective of numerical calculation and let people make decisions about conspiracy theories themselves. In 60 years of rockets, many facts come to light and some facts been swept under the rug and forgotten. Mathematics will give a clearer picture than thousands of hours of footage. Rocket science is a wide notion. In my opinion, the gyroscopic stability of rockets in flight is the highest or hardest solution in all rocket science. That is transition point to computer science. Gyroscopic stability was first computer usage in a device. The heart of any vehicle or plane is the engine. And rocket, the engine consists of fuel tank and oxidizer, liquid oxygen, turbine and pump which delivers fuel and oxidizer in combustion chamber, and last is Laval nozzle. The mathematical model to solve rocket velocity consists of three momentum terms. By remembering that momentum, same as energy measurement unit, sustains quantity conservation law, where a force unit, the thrust of rocket, does not sustain such property. The equation for rocket velocity V will be derived from such momentum equality equation. Here, capital letter M, mass of rocket, which is the function of time t. Small capital letter M, mass flow rate kilograms per second of exhaust gases with velocity W. V, velocity of rocket. V, index capital G, gravity velocity term. Capital M letter with index 0, rocket steady mass. The total sum of rocket construction materials mass, engine and equipment element mass, and payload mass. Gravity momentum term can be written in such manner. As we know from physics, velocity momentum is the same as force impulse. Multiply momentum equality by mass capital M letter. Insert gravity momentum equation in our equality, and by rearranging all terms we get rocket velocity from time t. Rocket velocity is dependable only from one variable, time t, where velocity of exhaust gases is pushing force. Not directly from capital M. Every period t, rocket gets lighter by losing mass due to consumption of fuel, and every period t will go faster. The opposite factor is gravity force velocity term with a negative sign. Rocket velocity must overcome gravity force, which is in process slows down rocket total velocity. Let's say we have a rocket with a total mass capital M letter with index 0 150 tons, from which 60% consists of fuel together with oxidizer. The exhaust gases mass flow rate from all combined nozzles per 1 second is equal to 720 kilograms per second. By knowing total fuel and oxidizer burning capacity, we can calculate the maximum operating time tau of rocket engines. Velocity of exhaust velocity is equal to 2000 meters per second. Exhaust velocity validation will be provided in second part of rocket science video. In comparison, 2000 meters per second is more than 6 times faster than speed of air in ambient temperature. The first part is the introduction to rocket science. All calculations done are not connected to any specific rocket module or rocket engine. This numerical solution must give a sense of mathematics behind the physics in rocketry. In the end, the maximum velocity of our rocket is equal to maximum velocity after 125 seconds of engine operation will be approximately 1800 meters per second. We assume that rocket always goes in straightforward direction and always is perpendicular to the ground. But before calculating the maximum height which rocket will reach, we will investigate the equation from the time variable by plotting the graph. Rocket velocity as time function. This graph is very important to debunk maybe not so famous theory, but still a conspiracy theory that the launch of rocket footage is slowed down. We know about the conspiracy theory about slowing down bouncing astronauts on the moon surface. This one is about the edited rocket launch. This graph perfectly shows that liftoff of rocket occurs only after about 5 seconds. This is a very important detail. Watch all liftoff video footages of heavy rockets, and you see that time delay exists for all heavy rockets. Engines are in full thrust mode, and the rocket starts liftoff only after about a minimum of 2 seconds and maximum after 7 seconds. That makes sense. A rocket must lose a lot of weight by exhausting burning fuel. The moment when rocket engine's thrust force equal to gravity force and rocket starts to fly upwards is question mark. Why not waste fuel by designing a rocket that exactly starts liftoff from 0 time period? Explanation is that theoretically calculated system requires an additional reserve factor. The second reason that rocket maximum mass consists constant engine thrust velocity and constant engine burning fuel mass flow rate must to be in perfect equilibrium. That is impossible task to achieve in practice. The rocket velocity is quadratic function plotted as parabola curve. The quadratic function is parameterized by time variable from 0 to maximum time interval value tau. To calculate the maximum height which rocket will reach after burning all fuel with oxidizer is the same as to calculate area h of rocket velocity from function of time. Our integration is from height range from 0 to h and velocity function integration from t index 0 till time tau in such expression. Integration results of maximum height of rocket when all rocket fuel was consumed is equal to the equation that shows rocket science in all its mathematics beauty and all its complexity. That is not the actual maximum value of rocket. Rocket velocity at this height mark is 1774 meters per second. Rocket reaches maximum height due to inertia force gained in process of launching, and actual maximum height is equal to. This maximum height is with condition if only the rocket all the time flies straight forward and perpendicular to the ground. The biggest drawback is launching of the rocket. In our example, from total 2 minutes and 5 seconds engine operating time, about 5 seconds have been used to make the rocket lighter by burning fuel without any effect on rocket velocity. And the advantage is quadratic steep velocity growth tendency over time. Also, in our example, a heavy rocket, 150 tons in total mass, not just can reach the moon, but also cannot reach a satellite height trajectory of 400 kilometers. Rocket weight is the biggest factor for a rocket's efficiency. The organization that solved these problems is Virgin Galactic. Their solution is to use a conventional plane as a launching pad. Mothership reaches 12 kilometers height and with initial speed of 160 miles per hour speed. When a rocket is detached from the mothership, and rocket in a small maximum 10-second period uses a solid fuel booster engine. Afterwards, when all solid fuel consumed, rockets due inertia force, same as in our calculation, reach about 85-90 kilometers height altitude. They accomplish two targets with one shoot. One shoot two birds at once, launching a rocket from 12 kilometers height with initial velocity of 160 miles per hour or 72 meters per second, and they achieved about 100 kilometers height very cheaply. I don't agree with money wasting on kids' toys for big boys. I just state a fact that is the only real rocket race solution for cheap, if you don't count $2 billion development costs cheap. The definite conclusion is that rocket launching is a very inefficient way to cargo delivery into space, aka height. As space tourism to see a vastness of space close to 100 kilometers height, you can send a high altitude balloon with camera for $300 maximum expenditure. That is all, folks. Thanks for watching. Please subscribe.